Hey everybody. Hope this works just fine. It's weird doing this and not being in class and everything like that. But I thought this would be a good option for explaining some things that are a little bit harder. The introduction to taxonomy was pretty straightforward, so I think you're fine with that, like what is taxonomy, basic things like that. I saw a little bit of confusion with some of the questions I asked you guys before, so I want to go through some of those, and then we're going to get into like how we actually, get into categorizing different species and what those relationships mean and how we communicate it, because that gets a little bit more difficult. Okay, so I'm going to try to not ramble. I'm going to skip through a decent amount of stuff here because I had you watch these different videos to do it instead of me talking. And I'm not going to do this for everything that we do. I just thought some of the more complicated stuff. So I'm going to try to keep this video not like 20, 30 minutes, something like that. Maybe you're laughing at me looking at how much time it ended up taking. So here we go. Let me skip through a little bit of these introductory things here. This is good. Okay, so what is your pointer? There's some confusion here when I asked you guys to pick an animal and list its taxonomical categories, all of its taxa, its address, so to speak, in taxonomy, meaning what are all the categories that it belongs to. Okay, and here they all are. I almost pointed to the screen as if you were behind me watching my screen, but so they go from domain to species, and as we're going down here, it's becoming more and more specific. So for domain, there's only 3 domains currently that we have listed of any living thing in the world. That's pretty broad. All the way down to species, where we have millions of species. So it's becoming more and more specific. All right, so here's an example. Red fox, like we have around here. Its domain is Eukarya, kingdom is Animalia, phylum, chordata, class Mammalia, order, family, genus, all the way down to its species. So a scientific name you maybe heard before, and I've said it a few times, is the genus and the species. So with the red fox, actually, its genus and species name is the same, so it's called Vulpes vulpes. Here is humans, to give you what we would look like. Down here, kingdom, it skipped domain. We are eukaryotes, right? We aren't prokaryotes or archaea. We're eukaryotic, so it's pretty straightforward. But so it should be eukarya. We're the animal kingdom because we're animals. We are chordates, meaning we have a backbone. Our class is mammals. We're mammals, right? Order is primates, and then you start getting into the family, hominids. And then our genus, Homo, we're the only one in that genus, and then our species is Homo sapiens. So that is our taxonomical address. All right. Some of you seem confused on that. So we'll skip through this. Like, what is a species, basically? If you want to go back and look at those slides, you can pause the screen. But there's challenges to this, right? What categories do we put these things in, right? Why is a fox Vulpes vulpes? Why is it in the mammal category? Why is it in the eukaryote category, right? Some are easier than others. So we've talked about this a little bit before, but here's some examples. Here's a pill bug. Here is a pill millipede. They look similar, sound similar in name and everything like that, but 2 very different categories of insects. This is a type of millipede. A pill bug is a totally separate group of insects. We've talked about armadillos and pangolins before. Armadillos, pangolins, both mammals. So they're both in the same class, but class is not that specific, right? Once you get to their order, they're in a different order, a different family, a different genus, and they're a different species, even though they look so similar, right? And we know that that is the case because we've talked about evolution, right? They share the same bony plates, a long nose, and a long tongue, and they roll up into a ball, not because of a shared common ancestor, but because of a similar role they're doing in their environment. That's called convergent evolution, and those are analogous structures. That's review. Other issues. Just because something doesn't look like it should be in a category doesn't mean it shouldn't be in that category. Examples. We've talked about both of these. Snakes. Snakes belong to a group called tetrapods. Tetra means four, pod or pod means foot, and it's just a category of animals that have four legs, right? So dogs, bears, primates, people, we have four limbs, right? Snakes don't have any limbs because they've evolved to lose those limbs, but evolutionarily speaking, they're still a tetrapod because their evolutionary relationship is such that they're more closely related to other tetrapods. Just because they've lost those limbs through evolutionary time doesn't mean they should go into this different category, because the categories mean their evolutionary relationship. So a snake should be closer to a lizard, which has legs, rather than a fish, which doesn't have legs because of its evolution. Okay. Some other challenges. For your average person, what we call an animal is confusing too. Here's some examples. This guy. It's an electric eel. It's not actually an eel. Red panda, a favorite of a lot of people. Not a panda. Not even red, really. The snake, it's a king cobra. It's not a cobra. It's a snake, but it's not a cobra. Naked mole rat, not a mole, not a rat. American buffalo, not a buffalo. So common names can be confusing as well. What I want you to focus on is, as I said before, their evolutionary relationship. So here's the important part. And these are going to be the last few slides. So this is how we actually communicate it. This is called phylogeny, or sometimes these things are called cladograms, or sometimes called phylogenetic trees. Cladogram is a little bit easier to roll off the tongue, but so this is called phylogeny. It describes the evolutionary relationship of different organisms. Not just because they look similar, right? If you just had a toddler categorize animals, that's not going to reflect their evolution, right? Maybe they just make a group of all fuzzy animals, and then a group of scaly animals, and then a group of flying animals. That's not actually their real relationships, okay? So we use these to communicate these ideas, and they're called cladograms or phylogenetic trees, okay? So this is based off of their characteristics, their anatomy, their fossil records, the DNA, right, is very, very helpful. All these things come together to tell us where a species should be on a phylogenetic tree, okay? So let me first show you like what they mean, okay? So you might see them like this curvy, or not curvy, but these diagonal lines, or you might see them with these like brackets, like a basketball bracket, right? They mean the same thing. They don't mean anything different. It's just a different way to write them. Okay, so this one is showing A and B are more closely related to each other, whereas A and C are more distantly related to each other. This is still showing the same thing. Notice B and A over here on the right are flipped, but that doesn't mean that their relationship still isn't the same. You can go like this. It doesn't matter, because if you trace them back, this is called a node, right here, a node. This is where you have a splitting, a branch in your cladogram. And that represents some kind of speciation event, right? So we could say A and B are dogs and wolves, right? Dogs split off of wolves some 10,000 years ago-ish. And that node, the splitting, is that event. So right where I'm pointing, or also right where I'm pointing over here. Okay. It gets traced back to the root, which is the common ancestor of all those organisms, whatever that might be. Let's say this is like dogs, wolves, cats is C. That works. The common ancestor would be whatever came before those and split off to all those different groups. Okay. So looking here at this example, let me make it bigger. Okay. So look at this example. This will be the last thing. Laser pointer. Okay, so as this is showing, here's my pointer. Crocodiles and birds are more closely related than birds and, say, primates. Right? You can trace their common ancestors. So crocodiles and birds, their common node or common ancestors right there, whereas birds to primates, their common ancestors back here. Birds to sharks is all the way back here, right? This is also showing different traits that you'd find on these different organisms. For example, this red line showing that they are all vertebrates. All of these organisms are vertebrates, meaning they have a backbone. Right? So they all share that characteristic. After here, they have a bony skeleton, meaning bones. We've talked about sharks, how sharks don't have bones technically, they're made of cartilage. So sharks are missing that. So notice if you were to follow this like down a highway and you took an exit off of sharks, they do not have a bony skeleton. Then you continue on, having 4 limbs. Everything in this group here has 4 limbs, whereas fish, sharks do not. Get more specific, an amniotic egg, meaning the egg is amniotic. So like amphibians don't have that. Down here there's a split. These organisms, rodents, rabbits, primates, have hair. Crocodiles and birds do not. They have eggs with shells. Rabbits, primates don't have eggs, so they don't have eggs with shells. So this is all correct traits for all these different organisms, and it shows how closely related they are based off of those traits. So that is why this one is the way that it is. So I'm going to show you one that's very similar to this, and I'm going to ask you a few questions on it, and that's going to be what you submit to me, okay? Hopefully you can't hear that. My dog is maybe going for a walk. Okay. Here it is. So there it is, nice and big. This is the one for questions. I'm going to ask you some questions on the Canvas page. This is the one that I want you to refer to. Okay? Sorry, slightly longer than I would have wanted. It's hard to condense things, for sure. Okay? I'm going to stop this. Boy, howdy do I hope it works.